What's happening, dogs? Mr. Allen here. We're about to work with some domain restrictions of radical functions, dogs. All right, let's get it. So, domain restrictions. We've seen them before with different types of functions. With polynomials, it's all real numbers. With rational functions, we got the fraction going on. We got to avoid stuff that makes our denominator 0 because you can't divide by 0. Now, when we're graphing in our xy coordinate plane, we're dealing with all real numbers, right? We only are dealing with real numbers there. So what's a no-no when it comes to square roots? I can't square root negative numbers and actually graph them, right? We know about imaginary numbers, but we're not graphing with those. So we got to keep things real, brah. All right. Now, can I square root 0? Yes, you can square root 0. So 0 is cool and anything larger than that, right? So positive numbers and 0. Well, I want to make sure this argument inside of my radical stays greater than or equal to 0. What if I were to just set up an inequality? So watch this. I'll say 2x minus 5. I want to make sure that's greater than or equal to 0. And if I add 5, I get 2x is greater than or equal to 5. And then I divide by 2, and I get x is greater than or equal to 5 over 2. So that right there is my domain, right? As long as my x values are greater than or equal to 5 over 2. I made that look worse. As long as it's greater than or equal to 5 over 2, we're good. You could also write this in interval notation, 5 over 2, comma, infinity. Parentheses on that, right? Brackets here means that we include 5 over 2 in our domain. The parenthesis means that we don't and we cannot include infinity. All right, so there we go. That's about it for the radical domain. Well, let's check out this one over here. Now I've got a negative, right? Now, in some situations, we can just be like, okay, what makes this 0? I got to be bigger than that. But you got to be careful with these things. So again, I'm going to go about the same process here. I've got 7 minus 3x. I want it to be greater than or equal to 0, right? It always helps to remind yourself, hey, why am I setting it greater than or equal to 0? It's because I can square root 0 and anything larger than that. As long as I make that 0 or larger, we're good. So now I'm going to subtract 7 on each side. I'll get negative 3x is greater than or equal to negative 7. I'm going to divide by negative 3. Anybody remember what happens when you divide by a negative number with inequalities? Any hands? Any hands? Any hands? Yes, you in the back. Yes, you flip the inequality. Yes, I'm going to have x is going to be less than or equal to negative. Negative is positive 7 over 3. That is my domain right here. Whee! Perfect. X needs to be less than or equal to 7 over 3. So the graph's actually going to be going the other direction here, right, than it normally would. And that is true because I have that negative in front of that x. That's a horizontal reflection. We don't need to go into transformations right now, but there's my domain. And as if we wanted to do interval notation, I'd be going from negative infinity to that 7/3, 7 over 3. Cool. It's kind of a terrible 7, but whatever. I'm having bad luck there. All right, and then the bracket for that one because I am including that 7/3. So a little rundown of domain restrictions with some more weird ones. We don't always ask you to graph these types, but we'll ask questions about domain to see if you truly understand what in the heck the domain restrictions mean, where they come from, right, rather than just a simple problem that we usually have you graph with like 1 or 2 transformations. That's it. That's dope, awesome, and rad. But cool. See ya.